This video is part 2 of a 3-part series focusing on 8th grade standard NC 8EE7, solving multi-step equations with variables on both sides. Students need to recognize the different situations that will arise in terms of solutions: one solution, infinitely many solutions, and no solutions. Now, solving equations can be modeled in a variety of ways. In video 1, we explored how to model both expressions and equations with algebra tiles, as well as some key concepts such as zero pairs and the properties of an equality. This video will focus on the concrete and the representational form of solving equations using algebra tiles by visualizing what is actually occurring as you move variables and constants across the equal sign to solve the equation. This video will be followed by part 3 that will model the connection from this representational to the abstract. For our example, we will use this equation: negative 2x plus 1 is equal to negative 4x plus 9. We will begin by modeling this equation with the appropriate tiles. On the left side, for negative 2x, we will use two negative x's. For positive 1, we will use one positive square unit tile. On the right side, for negative 4x, we will use four negative x's. And for positive 9, we will again use yellow tiles, 9 constant square tiles. Our first step is always to look on either side of the equation to see if there are like groups or like terms that we can combine. There are no like groups on the left side, nor any like groups on the right side, so we will begin to try to move our variables to one side of the equation and our constants together on the other side of the equation. It doesn't matter which side you move your variables to or your constants, nor does it matter which you move first, your variables or your constants. We're going to start with our variables, moving our negative 4x to the left side with our negative 2x. Now remember, in order to move any variable or constant, you have to create your zero pairs and then remove them. To create a zero pair with negative 4x, we need four positive x's. Whatever we do on the right side of the equation, we have to be sure to do the same thing on the left side, so we'll also add in four x's. Now we will match up our zero pairs. On the left side, we can see that we have two complete pairs to make a zero, and they will cancel each other out. On the right side, we have four complete pairs of zero pairs. All four of them will cancel each other out. Now we'll look at the values that we have remaining. On the left side, we still have our two positive x's, and we also have a positive 1, 2x plus 1. On the right side, we're left with all of our constants because of our variables canceled out, so we have a positive 9. Our remaining equation is 2x plus 1 is equal to positive 9. So we've combined our variables and removed all of those zero pairs. Now we want to focus on our constants. We want to focus on moving that positive 1 to the right side with the rest of the positives or the rest of the constants. So we have to think, in terms of that positive 1, what is the opposite of positive 1 that will create a zero pair? Well, the opposite of positive 1 is negative 1. If I add in a negative 1 on the left side, I also have to add in a negative 1 on the right side. Once I add in that negative, I can match up my zero pairs, and on the left side, my one complete pair will cancel out, and on the right side, my one pair will cancel out. Now I'm left with an even more simplified version of this problem. I have positive 2x is equal to positive 8. We're almost to the point of finding out the value of x. At this point, we just know what the value of 2x is. 2x is equal to 8. So on our left side, we're going to think about separate our values into equal groups. In order to do that, we want one x in each group. So we divide them into two equal groups. If we divide our left side into two equal groups, we'll also divide our right side into equal groups, giving each x the same number in each group. Now we can see that each x is equal to 4, so our solution for this equation is x is equal to 4. Let's look at an additional equation with a more complex setup. 7x plus 3x minus 2 is equal to 8x plus 8. We will model both sides of the equation with the appropriate tiles and then move the variables and constants until we have isolated the variable and found the value of x. To model 7x, we will use 7 positive x tiles. For positive 3x, we will use 3 positive x tiles. And for negative 2, we'll use 2 red unit tiles. On the right side of the equation, for positive 8x, we will use 8 positive x tiles, and for positive 8, we'll use 8 positive yellow square unit tiles. If you'll notice on the left side of the equation, there are 2 separate groups of like tiles, the variable tiles, on the same side of the equation. We first want to combine these into one group of x's. So we'll look at our 7x and our 3x's and we'll put them together to give us 10x's. And then we'll bring down each part of the equation that we hadn't combined yet, the negative 2, and on the right side of the equation, our positive 8x and our positive 8. Now, in order to solve an equation, we must put all of our variables on one side of the equation and then all of our constants on one side so that we can find our equal groups. Let's first consider how we can move 8x or make 8x's disappear. So the opposite of positive 8x is to add in 8 negative x's. Whatever we do on one side of the equation, we also have to be sure to do on the other side of the equation. Once we add in our 8x's on both sides of the equation, we can see that we can match up our 0 pairs, and on each side of the equation, our 0 pairs will cancel each other out. Then we're left with a more simplified version of the same equation. 2x minus our 2 is equal to, on the right side, we're just left with positive 8. Now we've almost isolated the variable. We've got all of our variables on one side, but we need to make all of our constants on the same side of the equation. So let's consider the opposite of negative 2. The opposite of negative 2 is positive 2. Well, if we add 2 positives to the left side, we also have to add our 2 positives to the right side. Now you can see that we have matched up a pair of 0 pairs on the left-hand side. However, on the right-hand side, there are no opposites to match up as 0 pairs, so we'll combine our positives with the 8 positives that were already there. So then our 0 pairs will cancel out, and we can look at our more simplified value of the expression. Positive 2x is equal to positive 10. Now we're almost there, except our variables are still grouped together. We need to make separate groups of our variables of 1 in each group. So we can make 2 equal groups for our variables, so then we also have to make 2 equal groups for our constants. Once we put them all into equal groups, we can see that the value of each x is equal to 5. Students should have multiple encounters in both the concrete and the representational stage in order to solidify the conceptual understandings of 0 pairs, properties of equalities, and how to move variables and constants across the equal sign while maintaining balance. For the concrete experience, students should model with the actual tiles so that they can have the opportunity to physically lay out the tiles to represent different types of terms, match up and remove those 0 pairs to simplify your expression, and really see the difference in what happens with the variable for each type of solution. During the representational phase, the teacher or the student may model with electronic manipulatives, and the student can use drawings to represent the variables and constants to show their understanding of the process. To review, our focus standard is NC 8EE7 solving multi-step equations with variables on both sides. We were focusing on building a conceptual understanding of the thought process behind moving variables and constants across the equal sign in order to solve an equation by representing those variables and constants with algebra tiles.